Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we continue our chapter from Mathematics 2nd, that is Probability Distribution, exercise number 7.1. Now, from exercise 7.1, today we see the example or question number 8, in which we have given a random variable x has the following probability distribution. Means we have to given a probability distribution for an discrete random variable or simply random variable, a table, and we have to find the values of different probabilities. First we have to find the value of k. P of probability of x is less than 3, probability of x is greater than 4, probability of x is greater than 6, and probability for 3 is less than x is less than 6. That is, we have to find the different probabilities. Now, to find the value of k, we use the definition that we know that here the summation of pi. We know that the summation of pi, that is sum of all probabilities, equals to 1. We use this definition or this concept. So here we write, since we know that summation of pi equals to 1. So take this addition. Take the addition of all these probabilities. So it becomes 0 plus k plus 2k, again plus 2k, then plus 3k plus k square plus 2k square, and lastly plus 7k square plus k equals to 1. Now, if we add this 7k square plus 2k square plus k square, 7 plus 2 plus 1 becomes 10k square, becomes 10k square. Then this k plus 3k plus 2k plus 2k, that is 2 plus 2 4 plus 3 7 plus 1 9. 7 plus 1 8, and this plus 9k. So we get 10k square plus 9k equals to 1. Now this can be written as 10k square plus 9k minus 1 equals to 0. This is a quadratic equation in k. We have to find the value of k, so factorize it. Here we have to find two numbers whose product is minus 10, and sum is 9, sum is plus 9. So such two numbers are 10 and minus 1. Such numbers are 10 and minus 1. So factorize this one. So this can be written as 10k square plus 10k minus k. This 9k can be written as 10k minus k, and this minus 1 equals to 0. So taking k common from these two terms, 10k common, so we get 10k into bracket, here remaining is k and here remains 1, so it becomes 10k into k plus 1. Now from last two terms, take negative sign common, so minus 1, and into bracket remaining is k plus 1 equals to 0. K plus 1 equals to 0. Now taking k plus 1 as a common factor, so it gives k plus 1 into 10k minus 1 equals to 0, which also gives now, that is k plus 1 equals to 0 or 10k minus 1 equals to 0. Now simplifying these two terms, we get k equals to minus 1 or k equals to 1 upon 10. K equals to 1 upon 10. But we also know that in probability distribution, in probability distribution, each pi is greater than or equals to 0, means probability, each value of probability must be greater than 1, must be greater than or equals to 0. Now here, if we put the value of k equals to -1, the probabilities, these probabilities becomes negative. Since for x equals to 1, it becomes -1. It becomes -1. For x equals to 2, it becomes -2. 2 into -1 means -2. So here k equals to -1. For k equals to -1, the probabilities becomes negative. So this k equals to -1 is invalid. So here we write, since for k equals to -1, for k equals to -1, probabilities of x equals to x, it becomes negative. It becomes negative, less than 0, and therefore k equals to -1 is not valid, is not valid value, and therefore we get the valid value, that is k equals to 1 upon 10. We get k equals to 1 upon 10. Remember here again, for k equals to -1, these probabilities becomes negative. These probabilities becomes negative, and we have the first condition that all probabilities must be greater than or equals to 0, that is non-negative. So k equals to -1 is not a valid value of k. So we consider only k equals to 1 upon 10. Now this is the first sub question, that is find the value of k here. Now to find k, probability of x is less than 3. So we consider now probability of x is less than 3. Now from table, observe that the values of x which are less than 3 are 0, 1 and 2. These are the values of x which are less than 3. So this probability of x is less than 3 can be written as probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Now putting these values for probability of x equals to 0, probability of x equals to 1 and probability for x equals to 2, these values from table are 0, k and 2k. 0, k and 2k. So it becomes 0 plus k plus 2k. And after adding these, we get it is 3k. It becomes 3k. But we know the value of k, that is 1 upon 10. The value of k is 1 upon 10. Putting this value, we get it is 3 into 1 upon 10. And therefore we can write probability that x is less than 3, it becomes 3 upon 10. The probability for x is less than 3 is 3 upon 10. Now for the second case, now for the second sub question, in which we have to find probability for x is greater than 4. We have to find probability for x is greater than 4. So here we write probability for x is greater than 4, which is equals to. Now again from the table, the numbers or the values of x which are greater than 4 are 5, 6 and 7. The values of x which are greater than 4 are 5, 6 and 7. So adding the corresponding probabilities. So this can be written as, that is probability of x equals to 5 plus probability of x equals to 6 plus probability of x equals to 7. Now from table, putting these values, we get probability for x equals to 5 is k square. For 6 it is 2k square. And for x equals to 7, it is 7k square plus k. It is 7k square plus k. Now if we add these, it becomes 7 plus 2, that is 9 plus 1, that is 10k square plus k. 10k square plus k. Now put the value of k. Put the value of k, that is 1 upon 10. So it becomes 10 into 1 upon 10 square plus 1 upon 10. So now 110 gets cancelled here. So we get only 1 upon 10 plus 1 upon 10, that is equals to 2 by 10. That gives 2 by 10. And so finally we get probability of x is greater than 4 equals to 1 upon 5 when we divide it by 2. When we divide it by 2, it becomes 1 upon 5. Now for third sub question. Now in fourth sub question, this is the third one. In fourth sub question, we have to find probability of x is greater than 6. Probability of x is greater than 6. And again, from table, we can see that a number greater than 6 or a value of x which is greater than 6 is only 7. Which is only 7. So, the probability of x is greater than 6 is nothing but probability of x equals to 7. Now the value of probability of x equals to 7 is 7k square plus k. So it becomes 7k square plus k. It becomes 7k square plus k. Now here we make the calculations. Now to simplify the calculations, first we take the k as a common factor. First we take k as a common factor. So it becomes k into 7k plus 1. This becomes k into 7k plus 1. Now put the value of k, that is 1 upon 10. Put the value of k, that is 1 upon 10. So it becomes probability of x is greater than 6 equals to 1 upon 10 into bracket 7 into 1 upon 10 plus 1. 7 into 1 upon 10 plus 1. Now this becomes 1 upon 10 into bracket. This is 7 by 10 plus 1. This is 7 by 10 plus 1. And so it becomes 1 by 10 into 17 by 10 by taking cross multiplications. And so finally it becomes 17 upon 100. It becomes 17 upon 100. This is the value for probability that x is greater than 6. Probability of x is greater than 6. Now last one. For the probability of 3 is less than x is less than 6. So the last one means fifth one. This fifth one, it is probability of 3 is less than x is less than 6. Now the numbers which are greater than 3 and less than 6. Greater than 3 and less than 6 are only 4 and 5. The values of x are 4 and 5, which are greater than 3 and less than 6. So this becomes, which is equals to probability of x equals to 4 plus probability of x equals to 5. Now from table, putting these values, the probability for x equals to 4 is 3k, and for x equals to 5 it is k square. So it becomes 3k plus k square. It becomes 3k plus k square. Now again taking k as a common factor. So if we take k as a common factor, it becomes 3 plus k only. It becomes only 3 plus k. Now put the value of k, that is 1 upon 10. So we get 1 upon 10 into 3 plus 1 upon 10. 3 plus 1 upon 10. Now again, if we make the cross multiplication and adding, it becomes 1 upon 10 into 13 upon 10. And so the final solution, that is probability of x is less 3 is less than x is less than 6, which is equals to 13 by 100. Which is equals to 13 by 100. So we solve this problem. In exercise 7.1, the question number 1 contains only the first 3 sub questions. That is, find value of k, find the probability of x is less than 3, and find the probability that x is greater than 4. And we add these 2 sub questions for considering all the cases for the finding the value of k, that is the unknown, and different probabilities. Now we take one more problem from miscellaneous 7. We take one more problem for miscellaneous 7 to find the probabilities. Now see, this is an example from miscellaneous. Here it is given that the probability distribution for discrete random variable is as follows. That is, we have given the values of x from 1 to 6 and the corresponding probabilities. Here again we have to find the value of k, then probability of x is less than or equals to 4, then probability of 2 is less than x is less than 4, and probability of x is greater than or equals to 3. Now again, by using the same method, we use the condition that summation of pi equals to 1. For probability distribution, the summation of pi is always 1. By using this condition, we find the value of k. Now putting the value of summation of pi, we get k, all these probabilities, that is k plus 2k plus 3k plus 4k plus 5k plus 6k equals to 1. Taking all the sum of k plus 2k, that is taking sum of all the probabilities, which are equals to 1 by the condition, or we can say by the definition. Now when we take this addition, 6 plus 5 11 plus 4 15 plus 3 18 plus 2 20 and plus 1 21k equals to 1. And therefore we get k equals to 1 upon 21. We get k equals to 1 upon 21. This is the first, that is the value of k. That is the value of k. Now next we have to find probability that x is less than or equals to 4. So probability that x is less than or equals to 4, which is equals to, now observe from table the numbers or the values of x which are less than or equals to 4 are 1, 2, 3 and 4. Here it is equals to sign is also given, so we also consider 4. So this can be written as probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3 and last plus probability of x equals to 4. Consider probability of x equals to 4. So now adding these two terms. For x equals to 1, it is given in k. For 2, it is 2k, 3k and plus 4k. From the table, the probabilities for 1, 2, 3 and 4. We add all these values. Now taking addition, it becomes 4 plus 3, 7 plus 2, 9 plus 1, that is a 10k. Now put the value of k, that is 1 upon 21. So it becomes 10 into 1 upon 21, and therefore for finally we get probability that x is less than or equals to 4 is 10 upon 21. The probability for x is less than or equals to 4 is 10 upon 21. Now the next sub question, that is question number 3. Question number 3, in which we have to find probability that 2 is less than x. 2 is less than x is less than 4. We have to find this probability, that is probability of 2 is less than x is less than 4, and from table it is clear that a number which is greater than 2 and less than 4 is only 1. Sorry, it is only 1, that is the 3. That number is 3. That is, we have to find probability when x equals to 3. So this is equals to probability when x equals to 3. And the value for probability of x equals to 3, it is given to be 3k only. So it becomes a 3k. Again, putting the value of k, that is 1 upon 21. Value of k as 1 upon 21. It becomes 3 into 1 upon 21. And so finally we get probability that 2 is less than x is less than 4 equals to 1 upon 7. Dividing by 3, it gives 1 upon 7. Now the fourth and last sub question, that is, here we have to find probability that x is greater than or equals to 3. We have to find probability that x is greater than or equals to 3, and the numbers or the values of x which are greater than 3 are 4, 5 and 6. So this probability of x is greater than or equals to 3 can be written as probability of x equals to 4 plus probability of x equals to 5 plus probability of x equals to 6. And so it becomes 4k plus 5k plus 6k, putting the values from the table. So taking addition, it becomes 15k. 6 plus 5, 11 plus 4, 15k. Now again replace the value of k, that is 1 upon 21. So it gives 15 into 1 upon 21. And so after simplifying, it gives probability that x is greater than or equals to 3 is 5 upon 7 by dividing 3. This is 15 upon 21. If we divide it by 3, it gives 5 upon 7. So in this way, we can find the value of unknown, that is a k, and different probabilities when we have given the probability distribution. Now in next lecture, we see the expected value and variance. The expected value, variance and the standard deviation for the discrete random variable x. Thank you. Here we will stop.